Solve the RL circuit assuming that R equals 500, L equals 4, and E of t is 20 cosine of 80t. Recall the RL circuit is Ri plus L di dt plus E of t. Substituting the variables, we have 500i plus 4i prime equal 20 cosine of 80t. We then divide by 4 to simplify the equation and rearrange it to write it in the form I prime plus 125i equals 5 cosine of 80t. But this is the standard form of the first order linear differential equation with p of x equals 125 and q of x equals 5 cosine of 80x. And so the integrating factor is I of x equals e to the integral of p of x dx, but p of x is 125. And so the integrating factor is e to the 125x. We then multiplying the differential equation with the integrating factor e to the 125t both sides of the equation, and we simplify. We guarantee that the left-hand side is the derivative of the product of the integrating factor, which is e to the 125t and I. You don't have to check this, but if we do, we notice that the derivative of this product is I prime times e to the 125t plus I times the derivative of e to the 125t. And so e to the 125t times I is the integral of 5 e to the 125t times cosine of 80t dt. And this can be evaluated using integration by parts. We will see that e to the 125t times I, the antiderivative is 1 over 881 e to the 125t times 25 cosine of at plus 16 sine of at plus the constant c, divided by both sides of the equation by e to the 125t, we get the general solution to the differential equation. Another example. A tank contains 600 liters of water with sucrose concentration of 0.2 kg per liter. We begin adding water with a sucrose concentration of 0.1 kg per liter at the rate of 40 liters per minute. The water mixes instantaneously and exits the bottom of the tank at the rate of 20 liters per minute. Let y of t be the quantity of sucrose in the tank at time t minutes. Set up the differential equation for y of t and solved it. We first observe that this is the mixing problem, but the rate in is 40 liters per minute and the rate out is 20 liters per minute. And so the rate as with the water enters is not the same as the rate as with the water exits. Some summary. We know that the inflow rate is 40 liters per minute. The outflow rate is 20 liters per minute. The sucrose concentration coming in at the rate of 0.2 kg per liter and coming out at the rate of y of t over the volume v of t. This is the concentration of sucrose. Where v is a function of t, initially the volume in the tank is 600 liters, but the rate in is 40 and the rate out is 20. And so every minute the volume increases by 20 liters. And so the volume as a function of t is 600 plus 20t. It is a function of time. With the initial volume of 600 and the rate increases by 20 liters per minute. Since y is a function of t, we want to find the rate in terms of y and t, kilogram per minute. So the rate in is 0.1 kilogram per liter times 40 liters per minute, and that is 4 kilogram per minute. And the rate out is the concentration, which is y over 600 plus 20t times 20 liters per minute, and that is 20y over 600 plus 20t, where y is a function of t. We simplify this to get y over 30 plus t. And so the rate at which the quantity of sucrose change over time, dy over dt, is the rate in minus the rate out. Also, when time is 0, initially, the concentration of sucrose is 0.2 kg per liters, but initially, there are 600 liters of water. So initially, there are 120 kilograms of sucrose. But this equation is the first order linear differential equation along with the initial condition. We should be able to solve it. This is of the form y prime plus pxy equals q of x, where p of x is 1 over 30 plus x. And so we're going to find the integrating factor. The integrating factor is e to the integral of p of x, but p of t in this case is 1 over 30 plus t. This integral is e to the ln of 30 plus t, which is simply 30 plus t. And then we multiply the integrating factor to both sides of the standard linear differential equation, simplifying this to get 30 plus t y prime plus y equals 40 times 30 plus t. But the left-hand side is guaranteed to be the derivative of the product of the integrating factor and y, which is 30 plus t times y. But since the derivative of 30 plus t times y is 4 times 30 plus t, it must be true that 30 plus t times y equals the integral of 4 times 30 plus t dt. Evaluate the integral on the right hand side. We have 2 times 30 plus t squared plus c. Isolate y. Y is 2 times 30 plus t squared plus c over 30 plus t, which simplifies to 2 times the quantity 30 plus t plus c over 30 plus t. But when t is 0, y is 120, so we plug t equals 0 and y equals 120 into the general solution we just found. And we see that c is 1800. So the particular solution is y equals 60 plus 2t plus 1800 over 30 plus t.